Mic check, mic check, mic check. Hello, am I audible? Hello. Okay, if I'm audible, we'll be starting in 7 minutes. I usually wait till 6:10, so. Hello, am I audible? If I'm audible, we will resume in. We'll start in 5 minutes. Let's wait for some more people to join. Usually by this time people join, but I don't know what happened today. Hello. Hi Prabhu. Good evening. No, why is so late today? Okay, no problem. So yeah, let me start. We are already late. Okay, so last week what did we discuss? I think we discussed. Just a second. Okay, so 26. Today we will discuss week 9 of this year and week 10 of last year. Let me check. Did we discuss week 9? Yeah, week 10 of last year. Okay. mean, if do you know anyone else who is like who is in this course and wants to join? Prabhu. I'm saying, do you know anyone of your college who has taken this course and hasn't joined the session till now? Okay, no problem. I will keep on updating the attendance when people join. So yeah, how many assignments have you finished till now? Submitted. 10th week submitted. Okay, so I think we can discuss 10th week. You have submitted? Do you have any doubts? No problem. Let me increase the attendance. Yeah, I mean, they were simple questions only. So anyways, I'll discuss week 9 and week 10 of this year, and I think week 10 deadline is not over yet for this week, for this year. Yeah, so we will not discuss week 10 today. Also, I will be taking an extra session. So sorry, where is that? I will be taking an extra session after these 12 weeks are over. There I will basically give you a revision of all the concepts, so that all the assignments and everything in 2 hours we will revise everything. Okay. Yeah, so that's why. So before exam, before a week of, when is the exam? Okay, so no problem. We will have it in April mid. Like this is March 28. Then, as per my calendar, we will have 2 more sessions. So after that, just after that, I will create one more class. But I will ask NPTEL team to create one more session, because that's what I'm allowed to do. Like at max 1 more session. I cannot take 2 more sessions. So yeah, that will be it. Let's start week 9. So decision tree bagging boosting I explained last week, if you remember, if you were there last week, right? Prabhu? Yeah, so I told like there are 2 types of things. Let me just put my April 27. Okay, then it's fine. We can do something about that. We can have a session around April 20 or something. That leaves you plenty of time to revise. Okay. It's a computer based exam and it will not be open book. So it will be an MCQ exam, as all NPTEL exams are. You have to tick like the way you do the assignments. It will be that way only. Okay, you don't have to worry about that. So like these questions are there. Let me share my screen. Sorry, is my screen shared or not? No, no. Okay. So like these questions will be there, like these only, and around I would say 50% of the paper comes from assignment itself. Okay, so solve everything, go through all the solutions, solve everything. Okay, the solutions will be available to you by the faculty, and then you can solve everything. You should solve everything actually. It's because like 50% marks you can just score from assignments, 50-60% marks. The rest of the marks will be like questions will be somewhat different, but they will be derived from assignments only. 50% questions might be exactly from assignments. Okay. Yeah, so will there be 2 sessions? Yeah, there are 2 sessions, and there will be 2 papers as well. Good evening, Praveen. So session 1 paper will be different, session 2 paper will be different. Okay, there will be some overlap, but that overlap, I would say, like since I said the 50% questions will be, so 50% in session 1 and 50% in session 2 will be from assignments only. That you can assume. Values might change, but the like if you mug up, it's of no use. But values might change a bit, but the solution will be like the same. In solve it, you can solve the questions in the same way only. Okay. Okay, so last class I discussed the previous week's assignment, and this session we will discuss week 9 and week 10 this year and previous year. And after deadline is over, I will discuss week 11, 10, and 11. Okay, so yeah, shall we start? Okay. So see, um, what is the main problem with decision trees that bagging helps? See, I already told in last session, the problems are of bias or variance. Okay, either it will be bias or it will be variance. So variance problems are handled by hacking the data, and bias problems are handled by hacking the model. Okay, so decision tree performs bagging. Bagging means splitting data and passing. So it basically helps in splitting data is like solving variance problems. So it solves the problem of high variance. Okay, it's easy question. I'm explaining it to you, but anyways, it's an easy question. Any doubts in this? Like, or should I explain it again? Prabhu, Praveen, cool. In KNN, K represents the number of neighbors. Yeah, it's very simple question. I don't know, like, I don't think so. There should be any doubt in this question. Gradient boosting. What is being fitted each? See, in gradient boosting, what is being fitted in each iteration? See, the gradient of loss function with respect to predictions. I told in last class, right? In first epoch, we take gradient of output, and sorry, in first iteration. Okay, at first number, we have the number here. Let me add the attendance. At first iteration, first step, it basically takes the output. Then from in further subsequent steps, it keeps on doing the same thing on the loss itself. It tries to minimize loss by setting loss equal to 0. So yeah, this is the answer. It computes gradient of loss function with respect to predictions. Easy. Any doubts in there? Okay. What is typically chosen for the number of features D to split? Last class, I think Praveen asked this question. Praveen did it. Yeah, so I told na it's not all and it's not half. It's something like I said it's not half, it's not log or something like that. All or something. So it was obviously it was square root of number of features. Okay. So why do we do that? So it's basically a rule of thumb, I would say. So assume you have 7 features or say 16 features. So if you take 4 models, then the weights that like each model gets equal number of features, right? Am I right, Praveen? Okay. So 4 models, 4 features each. If I have 49 features, then 7 models, 7 features each. Correct? So this basically helps in equally distributing features so that one model should not learn a lot of parameters or models should not learn everything at whole. So what's the problem with number of features? It increases complexity. So that's why if we reduce, say, if I create one model for each feature, the problem with that is very simple model. It will create cause bias problems. Okay, so if we put all features in one model, then it again complicates it, creates a very overfitted model. So that's why we perform some sweet spot. Sweet spot is square root only. Okay, any doubts? You say yes or no, then I'll move forward. Cool. In ADA Boost, I mean, if you have watched the video, it's like a simple step-by-step process. You increase the weight associated with it. Okay, so like you If there's a misclassification, they are given higher weights in next iteration. So if you increase the weight, in that way the model will learn the boundary around them, and that way you won't face the problem of misclassification on that data point. Loss function associated with data boost. Data boost usually uses exponential loss function. That is clear in the video. That should be clear in the video. Okay. Which metric is not typically used to make splits in decision trees? Gini index entropy classification error. Mean square error is not used because mean square error is associated with. Yeah, Praveen. Yeah, why? For classification. Exactly. See. See this, I'm highlighting. It's a binary decision tree. Yeah, so that's why these things are used and this is not used. That should be clear to you, right? I mean, that is clear. Now next, shall we go to the next question? So in K means how are clusters centers are typically initialized. So it's first initialization is random. Okay, then we try to learn centroids. Okay, so yeah, that is the answer. First initialization is random. So we randomly within the range of the data. That should be clear. I don't know. It's easy only. What is dendrogram in context of hierarchical learning? Dendrogram is a tree-like structure. Dendrogram, dendrites. If you had studied biology in your class 10th or something, if you have come across this concept of neuroscience or brain, then you might know this thing. That dendrites are the leaf-like structure below the axon, that neural what we call node of Ranvier, etc. I know. I took the course. I took a course here, so that's why I know this much biology. Otherwise, I'm not a biology student. So dendrites are like tree-like structures representing the hierarchy of clusters. So that is all about dendrograms. Key advantage of using hierarchical clustering over K means is it does not require specifying number of clusters beforehand. So like, well, however deep you want to go, you can create another cluster as per your convenience. You do not need to worry about specifying the requirement of number of clusters beforehand. Clear till now? Any doubts? Okay. Yeah, let me check my iPad. I might need to solve week 10 of last year. Okay, I'll connect it later. Any doubts till week 9 or any other doubts which you might have faced till now? Then we will go to last year's week 10. I'll also give hints in this year's week 10, but for now let's solve this one, okay? Any doubts till now? Okay. So last year's week 10, assignment 10. As per our records, you have not submitted. Obviously, I didn't take the course. So, suppose you are using dimensionality reduction as pre-processing technique. Instead of using all the features, we reduce data to k dimensions with PCA, and then we use these PCA projections as our features. Which of the following statements are true? K is the number of features remaining with us. Okay, a higher value of k means we have to we basically take all the features. Say like I have 20 features, I take all the features. So higher value of k means less regularization, lower value of k means more regularization. We take more regularized features because the weights are preserved, the variance is preserved in like initial features, so it makes no sense to pick all the features like this. Okay. Regularization means so whenever you take some weights, okay, so some of the weights become so small that they uh, like what should I say, so large or so small. How should I show you? Let me connect my iPad. Okay. So the concept of regularization should have been taught to you last one, ridge regularization. So that's the same thing. Otherwise, if you don't know, I will explain it. Where's Google Meet? Mm-hmm. Correct. Yeah, I mean that is correct. Just a second. Let me sign. So yeah, we reduce overfit, but how do we reduce overfit? Exactly. Let me show you. Let me show you. So assume you have a loss is equal to something something. Okay. Now assume you move your weights. Your loss is like this, and your weights are moving like this. So you basically perform gradient descent like this. Okay. So generally you move from higher weight in magnitude to lower weight. Okay. Problem with this is if you are overfitting or if you are doing something, so ultimately you will come here, right? You will come here if you are like over doing something. So that means the weights, most of the weights will be closer to zero. The problem with that is those weights will render the model redundant. So what you do is you add something to the loss. Now, so assume you have a very high weight, or assume you have a very low weight. I'm telling this in context to high weight. Okay. So suppose your loss function, this is zero axis, this is zero axis. Now if I remove this zero axis from here and I add this zero axis here somewhere, this loss is zero, but this loss is zero. Okay, this is very good, but your weights, sorry, I add the weights here, I add the magnitude of weights here, magnitude, but magnitude of weights is very high. This means this total sum is very high. Okay, so this means that I should go somewhere here towards lower weights. I'm regularizing the weights. Okay, getting it, Praveen? Okay, so when this you come to this side, you have some loss equals to high and weights equal to low. Again, it's a very difficult situation. So we get to something like mid, where these both values are mid, and we get somewhere here where the weights are up, like somewhat good and loss is somewhat good. Okay, so ultimately this is what we do in regularization. So what did we do? We prevented the usage of all the weights, like very like magnitude wise. So now our weight range is limited. Now our weights will be won't be from 0 to 200 our weights will be from 0 to say 50. Okay, so now we have created a certain range of weights. They are not exploding, the weights are not exploding. So this is what you are doing here. Once we do PCA, assume this feature preserves 70%, this feature preserves 20%, and this feature preserves 5%. Remaining all features preserve 2% only. What's the use of taking them? No use, because this is just 2% of the data they are preserving. The whole data is getting preserved here, almost 95% of your data. Okay, got it? Praveen? So this means like we have 1, 2, 3, 4 features only. So we will have corresponding 4 weights. If we take these small features, such suppose there are 20 features. Okay, if we take these to 20 features, now we'll have to create 24 weights. Ultimately, these weights, what will they create? They will create noise, they will create overfitting, higher number of weights, higher overfitting. So basically, reducing this k means increasing, like k is reduced. This means regularization is increases. This is the general concept behind it. Clear? Is it clear? Reducing unnecessary weights. So like their contribution is very small. If we take them and they ultimately get very high value or something like that, the whole thing just like goes bizarre, something like that. So yeah, that is it. Um, this question, this is Gaussian distribution. We all know like what is the correct answer. This is negative of, yeah. Sorry, screen is not visible. I don't know why can't I share two screens. Let me just pin it. This is pinned. Not visible. Okay, I don't know. Okay, let's leave this. Let's just go here. This PCA question is here. The Gaussian distribution question. We all know the formula of Gaussian distribution. You can simply apply this formula. Okay. So generally this is sigma square into square root. This is the very formula. I mean, very simple. PCA is a dimensionality reduction algorithm. Which of the following statements are true about PCA? PCA is unsupervised. It searches for directions that have largest variance. Number of principal components is less than number of features. All components are orthogonal to each other. All are correct. Clear? Given that this is evidence, this is prior, this is posterior, this is likelihood. Okay, sorry, this you have to match it. Okay. I think A should be this. This should be posterior. Y given X. This should be likelihood. Likelihood of X happening given Y. And the remaining evidence is your I would say X, which should be evidence, and Y should be prior. Given prior, you have some evidence that becomes posterior, and yeah. So evidence is always Y. Just remember, because there is Y. That's why we have X. Okay. Okay. You draw n IID random variables yielding to this. Suppose you have some Bernoulli distribution with a known parameter p. What is P? What is P? MLE. The maximum likelihood of parameter P. PMLE. I don't know. I forgot the formula. Let me just chat GPT this. Okay. Okay, so basically IID, the MLE of P. P is the, say, what is P? Unknown parameter. Okay, so 0. Sorry. Zeros means this probability doesn't exist, 1 means probability exists. Okay, so that is as per ChatGPT, the final answer is 8 by 10 because 8 ones are there and 2 zeros are there, that is 0.8. Sure. Mm-hmm. 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 Independent and identically distributed. IID means that. Okay, so I mean these random variables are independent and identically distributed. Okay. Cool. Uh, Let me show you the solution. I mean, I can see on ChatGPT. It is a very simple formula to keep it. Anyways, let me show you the solution. And I think I should show solutions only. Like, otherwise I'll have to share my screen from there. That becomes very difficult. See, are you able to see the solution? You have given sample number of successes is 8, number of observation is 10. MLE of P is number of success by number of observation, 8 by 10, 0.8. Got it? You have to study Bernoulli distribution. Go and study Bernoulli distribution. Okay. Bernoulli distribution. Search. So open Wikipedia. You will see. Okay. So Bernoulli distribution is a I would say binary distribution where you get zeros and ones. It's not a continuous distribution. It's a discrete distribution as well. It's one of the discrete distributions. Like I think the only one there is a variant of it, but this is it. I mean this is Gaussian, but this is Bernoulli. So where the possibility of something not happening is very low, or possibility of something happening is very low, in that case it's a Bernoulli distribution most of the times. Okay. So you had tails or Bernoulli distribution. I mean, there's some other distribution. I forgot the name. I think. Anyways, just study this. A lot of statistics is here. That is, I think, out of scope for this course right now. Okay. There are two boxes. First contains 3 white, 2 red balls. Second contains 5 white, 4 red balls. Ball is drawn randomly. Is it shared? It is shared. Are you able to see it? Okay. Oh, sorry. Probability, you have to find that the ball was drawn from second box. So you have to find, you have box 1 and box 2. You have to find probability 2 given white. Okay. So you have like A and B, you can make the boxes A and B. So you have probability W given white given A is 3 by 5, white given B is 5 by 9. Okay, so I have to find this thing. Probability of B given white is this thing, and you can compute this thing. These are all given. Okay, so you have to compute probability of B here, like probability of W here. Ultimately, it should be probability of B intersection W, that is probability of W given B into probability of B divided by probability of W. So probability of W is probability of W given B, and this is simple, like this is summation probability, summation of rule. Okay, so that way you can solve it. Answer is 50 by 104. Try solving it. I will upload the solution. Let me upload the solution as well. Okay. Question number 7. In order to find maximum likelihood estimator of a parameter, we find likelihood function. We maximize it with respect to theta, solve for theta. Just a second. Okay, what are the steps we do to maximize likelihood function? We take derivative, set it equal to 0, solve for x. Ultimately, yeah, that's what we do. Ultimately, we have to find the like minima or maxima. Okay, so how do we find minima maxima? You take derivative, set it equal to 0 to get the point of inflection, and solve for theta. Clear? Okay. Given a full deck of cards, you attempt to draw from it with the goal of getting a coin. You replace card and reshuffle deck at every instance. Which of the following is true? Okay, so yeah, independent identical distributed, that is IID. I mean, you are getting the same set again. If I shuffle, I draw a queen, and if I remain keep it as it is and I draw it again, so it's not independent because it's dependent on previous instance, and it's not identically distributed because the cards were 52, now are 51. Okay, so the identically same experiment should be when the set is replaced again. Now that is the example of Bernoulli trial, obviously. Okay, Bernoulli, yeah, it's Bernoulli trial. The probability of getting queen is different from probability of getting jack. No, I mean they have given it. There are 4 jacks, 4 queens, so the probability should be same. Clear till now? Any doubts? Sorry guys, can you like wait for 5 minutes? I just need to take a break. I need to drink water. Water is more than well. I need to go fetch it. Thanks. Okay. Yeah. So I need the. Let's start. Let's start. Okay. Am I audible? Okay. I've been given very easy question. You are given some data points. You have to find mean. Mean is summation by number of data points. They should have done it the same way. Standard deviation. Standard deviation is this formula: mean minus number, and sum over it. Now divide. Okay. So yeah. Ultimately, you know the formula for the standard deviation. So these are the final two questions. I mean, very easy questions. Mean and standard deviation. So yeah, we are done with this last year's week 10 as well. I can help you solve week 10. I mean, I will not solve it, but I can help you like work the solutions out. Okay, so yeah, just saw this thing. Number of successful experiments upon total number of experiments. Okay, so number of successful experiments should be m, total experiment should be n. Okay, am I right? Yeah, yeah. According to central limit theorem, what happens to distribution of sum of n? It becomes Gaussian ultimately. Yeah. Just I'm discussing it. Like you cannot become like they are very simple. What I cannot debate around it. It's a theorem. Okay, so the covariance matrix is proportion. The covariance matrix of multivariate Gaussian distribution is proportional to identity matrix. The shape of contours will be constant probability density. You have what should be the answer? Just a second. Hold on a second. I'm getting a call. Hello. हेलो. हाँ. कॉपी में मैं NPTEL चल रहा है भाई अभी. एक काम करो ना, सुनो सुनो. गौरी मैम को कॉल कर दो. गौरी मैम को बोलो, वो ले लेंगी. ठीक है. चाबी किसके पास है? हेलो. चाबी किसके पास है? चाबी किसी से पूछ लो एक बार. मेरे को दे देना. ठीक है. मैं ले लूँगा, रात में आके ले लूँगा अभी. ठीक. मेरे को ना वो कल कॉपी दिखानी है. कल बहुत काम पड़ा हुआ है उधर, वो कराना सर्वर वगैरह वाला. ठीक है. ओके. हेलो. Am I audible?
Yes, sir. Audible.
Yes,
sir. Audible.
My earphones are disconnected. Now it should be audible. In just a second. Okay, just a second. Let me rejoin. Let me rejoin. Okay. Hello. Mic check. Mic check. Mic check. Am I audible now? Hello.
Yes, sir. Audible.
My earphone is not getting connected. It should. It's not. Okay, just a second. Just a second. Hello. 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 Am I audible now? Prabhu. Oh, sorry. Hello. Am I audible now? Cool, cool. Yeah, so like try figuring this question out. I don't know the answer. I'll have to study this thing. Or I'll have to take an example and solve it. So there should be some theorem around it. Multivariate Gaussian distribution. I think it should be this thing, circles. Because I do some research around it. So as per my theory, the theoretical, what should I say, intuition, it should be circles. Or it should be tilted ellipses. If it's a diagonal matrix or not, identity matrix. Identity matrix is all one, right? If it's all one, it should be circles, I think. Yeah, so it should be circles only. Anyways, when using naive-Bayes classifier, what rule is used to assign new observation? This one. Correct. Given a data set with features X and classes C, naive Bayes is correct. Yeah, what is the probability of probabilistic interpretation of least square cost function? Least square cost function. Bayesian error rate, likelihood. It should be Bayesian error rate. It should be or not. I don't know. It minimizes. I don't know. Try figuring it out. I'm just solving the questions which I know for sure. Matrix factorization is single value decomposition. Yeah. Yeah. Correct. Sorry. Boundary in support vector is that should be W transpose X into Y should be greater than 1. Ultimately, because if you don't add Y, like for negative samples, you don't know the direction. Okay, so I don't know if my tablet is so. Assume this is a plane. This is a support vector plane. Okay. I have a point here, and I have a point here. Let me hold it like this. I have a point here. I have a point here. Yeah, the equation of this plane is this vector. The equation of plane is one line that is perpendicular to it. Okay. How do you find the distance of plane from a point? You multiply this equation of plane into line. Okay. Okay, so the direction is in the point, this direction. Okay, in the direction of point. So if this is the case, if you multiply it, you will get positive value. If this is below, you multiply it, you will get negative value. Okay, so it should be either greater than 0 or less than 0. Yeah, sorry, yeah, this is the correct, you are right, this is the decision boundary. So what you do is, whenever you multiply y is to ensure that you don't have to worry about the sign greater than 0 equal to 0. So I assume that this direction contains negative samples and this direction contains positive samples. So if y is positive, y is 1, I multiply 1 with output, it is positive. This is negative, so this, I mean, the other class should be 0 or minus 1. So I assume this class is minus 1. So I multiply minus 1 with y, with this product, I get positive value. So in this way, I can just get a positive value representing both the directions. So ultimately, if you want to find, you have to use this greater than 0 something. So yeah, this is it. This should be the correct answer. See, this what constraint is applied to ensure data points are correctly classified. I think this is the constraint which is applied. Okay, the greater than 1 is basically used to determine that the point should be somewhere far from that line. It should not just be touching that line. If it's greater than 0, it can be like just touching the line. The support vector should have some gap between it, so I think that's why it is greater than 1. Okay, that is like, these are intuitions, okay? Okay, so last question, how will you determine if maximum matrix shows different distribution? Solve it. If I solve it, it will be like very descriptive solution. Try solving it yourself. If you don't solve, if you're not able to solve, okay, we will discuss it next week. So yeah, this is the end of assignment discussion for us. Uh, yeah, yes, yes. Okay, 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 okay. Somewhat I got, somewhat I missed. Like, can you just type what is the exact question you are having? I got the gist of it. Can you just type what is the exact question you are having? Like, you can, if you have values, you can directly give it. Otherwise, it's not preferred to give these values. You know why? This is the data which you already know. You computed it, the mean and etc. given on the data yourself. Okay, the model should not see this. Model should compute all these things automatically. If it sees this thing, it will assume, start assuming that this is the mean only. I mean, if some new data comes up and mean changes, so model will just gets its whole thing disturbed. Okay. Yeah, yeah. So, they didn't get the question. Still I'm not able to understand. Yeah, please share it, please. Just to find. You can share your screen if you want to show something. Yes. I don't. I don't think so. I don't think so. We can train a model on these. These can be used for statistical analysis type of thing. You can draw by like charts and all. What we call box plot, just to know how are these things behaving. But I don't think so. They can be used to train anything. Like if you take the mean of let me show you, the mean of phosphor and sulfur is same, almost same. Okay, then their minimum is same, their maximum is almost same, then their standard deviation is almost same. So their distributions quite like overlap quite a lot. So even if I try to like train model based on this feature only, it's impossible. I mean, I don't know if it will work or not, but it doesn't give me any confidence. Okay. Mm-hmm. Okay. Okay. If the range is given, you can basically create a Gaussian function like to create a synthetic data. So like you can give it, this is the range, okay, and create a Gaussian function over that with some peak, and then you can sample some values from it to represent iron, to represent nickel. In that way you can have a synthetic data, but that synthetic data will still not represent real world data, and that may help you somehow, but I don't know to what extent. Okay. You can just email me. You can email me. My email ID is already shared on that portal, that question answer portal, and also like you can see it here itself. I don't know if it's visible or not. That's I'm also facing some similar issues. I have like to complete 3 papers by the end of this month, and I have rebuttals planned. Anyways, okay. Any other questions regarding this thing? Hello. Sorry. I don't actually. I don't have. No, no. My work isn't core CS, NLP graphs and all. I don't work in this domain. I don't know if anyone works with this domain or not. Mm-hmm. Yeah. Yeah, I think then you can contact those people who work in this area. Like if you see their paper, you can email them and ask them. They might be able to help you out. So what? Like you can like collaborate internationally. It's not a problem. Okay. Anyways, I think that would be all around this. I don't know if I can help any in this. So any other questions, guys? Any other people who are here? If you have any other questions, just let me know. Otherwise, we will wind up in 2 minutes. Okay. Prabhu, Praveen, Swaroop, Anand, Anand is fine. Okay. I think we are going with good pace. I mean, the course is not that much heavy. Doesn't take a toll and doesn't even take a lot of effort from my end as well to explain things. Anyways, I think then that would be all. We can meet next week. Okay. And discuss the same setup we follow this week. Hello? Hello? Yeah, sorry, some network issue happened. But I was saying, let's meet next week and discuss what in the same setup we follow. You guys uh, follow the assignment first, and then we'll discuss in detail, and we'll solve week 11, and after that week 12, and then we will have an extra session as I talked with Prabhu. We will have an extra session week 13, where we will discuss some of the remaining assignment. One assignment will remain. I will discuss that and we'll revise everything from start to end, all assignments. I will give you a list of topics which you should study, and that will help you out to finish this, to revise and give exam. Okay? No, no. But all courses, all NPTEL exams are MCQ based only. Don't worry about that. The questions are comparatively simple. It will be multiple choice only. It will not be mostly even. It will be multiple choice. Ha. Yes. Chalo. Then thanks a lot, guys. I'll take leave and let's meet next week. Okay. Thanks a lot. Bye bye. Okay. Good night.